Welcome
to the review for chemistry class.
Today we will be learning about Boyle's Law and Charles' Law.
First, we will be talking about Boyle's Law.
Boyle's Law states that pressure and volume have an inverse relationship. This can be demonstrated with the graph below, as you can see here. The formula for the law is P1 times V1 equals P2 times V2. To demonstrate Boyle's Law, we will be using the demo of suction cups. Now, suction cups, the way it works is when it is pressed against the object, whatever you're doing, so this would be the fireplace against the wall or whatever, the pressure outside of the suction cup is greater than the pressure inside of it, causing it to stick to the object or wall. But when this is released from the wall, the pressure inside of the suction cup, which would be in here, is equal to the pressure outside of the suction cup. For the next demonstration of Boyle's Law, we will be using Jenna to show how a straw works. Now, the pressure at the one end where the liquid is in a cup, like a drinking glass of water or anything else, is greater than the other end of which you are using to drink. So this causes the liquid inside of the cup to go up to the other end of the side. So that's how you drink. Now you're on to our example for Boyle's Law. As you can see from the problem, 2.5 liters of a gas of standard temperature and pressure is compressed to 0.473 liters. What is the new pressure of the gas if the temperature is constant? And now we have to find our variables because you know Boyle's Law is P1 times V1 equals P2 times V2. So as you can see, it says at standard temperature and pressure, so we are using standard pressure, which is, as you know, an ATM1. So as you know, so that's 1 ATM. And it would be times, because we're multiplying. Now we have to find our V1, which as you can see at the very beginning is 2.5 liters, and liters is volume. So it would be 2.5 equals. And now it says, what is the new pressure of a gas? So we're solving for P2. So this would be our x variable, and this would be times, or I'll make it times. And now we have to find our V2, which in this case would be 0.473 again. So it would be times 0.473. So after that it would be 0.473x equals 2.5. Now you have to divide by 0.473 and divide by 0.473, which equals 5.29. And then that's it. That is our answer.
So now we are going to be talking about Charles' Law. And Charles' Law states that volume and temperature have a direct relationship in a gas at a stable pressure. You can see in the graph below, as temperature is increasing, volume is also increasing. And the formula that is used to pursue Charles' Law is volume 1 over temperature 1 is equal to volume 2 over temperature 2. Okay, so for our first demonstration of Charles' Law, we will be showing the can crush activity. So we have a can that's been sitting in hot water for a while now, and when you take it out and put it, oh my, Jesus, that's hot. Take it out, put it in the cold water, it will crush, like so. I will bring it over, see if everyone can see it. Dump this water out. There we go. And the can is crushed on the sides and everywhere. So this shows how temperature and volume are related. So when the temperature is decreased very rapidly, the volume inside is just gone, and the volume outside is a lot stronger, collapses the can when it gets colder. So yeah, there's our first demo. So for our last demo, we will be showing how the volume of the balloon changes when submerged in different temperatures of water. So this is the balloon at room temperature. Obviously the volume is normal, temperature is normal. When we submerge it into the hot water, well, we'll start with cold water. When we submerge it into the cold water, we will see it start to shrink. It's shrinking because the temperature is decreased, which means the volume inside of the balloon is also going to decrease because of the direct relationship that Charles' law states. And we will leave that in there for another like 5 seconds. And now when we bring it out, we can see that it is definitely smaller. Water's dripping everywhere. So now we were going to put it in the hot water. So this water is extremely hot. And now that it is in the hot water, it is going to start to expand because the temperature is increased, which means the volume is also increasing. And I don't want it to get too big, but as you can see, it's definitely got a lot bigger. I'll put it in for a little bit longer just so that we can really see. This water's really hot. Okay. Yeah, it's definitely gotten a lot bigger because, again, the temperature has increased. Volume's going to increase. One more time in the cold water. Quickly shake this one back down. Small again. Alright, so that demonstrates Charles' law. So now we are going to be doing our example equation for Charles' law. So as we know, the equation that we use is V1 over T1 equals V2 over T2. So let's try and find our variables, as our question is a 4.5 liter sample of gas is warmed at a constant pressure from 300 Kelvin to 350 Kelvin. What will its final volume be? So let's start with finding our V1. A 4.5 liter sample of gas, so there's our V1 right here. So we'll write that. Grab a different marker. 4.5 liters is warmed at a constant pressure from 300 K. So this would be our T1, our first temperature, to 350 K. So that would be our second temperature, as we will be solving for x because we are finding what its final volume would be, aka V2. So when we do the math, we get everything down. Basically, we would be doing 4.5 times liters times 350 would be equal to 300 K times x. When we go about that and we solve this problem, we would be getting the answer of 5.25 liters. And that's our final example.
So in conclusion, we hope you guys learned a lot from this video. Go back and replay it as many times as you need, and good luck in finals.
Yep. Thank you. Bye.